Okay, so we are doing 3.1, and it's called Extrema on an interval. Okay, there's going to be a lot of words that go into this, which is great that we can do it on video so you don't have to write all it down and don't have to watch me write it all down. But we're going to read through it together and then we'll talk about it. So we're going to let f be defined on an interval I. So that's just the interval talking about. So think of interval like from 2 to 4 or negative infinity to infinity, containing a value c. 1, f of c, meaning that value has been plugged into the function, it'll be called a minimum on the interval I. When I plug that value in, f of c, it's less than all the other values that are plugged in. Okay, which makes sense. It's going to be a minimum if it's smaller than all the other values. And then 2, f of c is going to be maximum then if it's greater than all the other values when c is plugged in. Okay, the minimum maximum value of a function on interval are the extreme values or extrema. You'll hear them used interchangeably. Okay, and of the function on the interval, then the minimum maximum of a function on an interval are also called the absolute max and absolute minimum is what I'll call them. But you can also see them as global min and global max. Extrema can occur on interior points. So that means somewhere in between the interval, endpoints as well. Okay, so just keep that in mind. Extrema that occur on the endpoints are called endpoint extrema. And we'll see some other concepts as we talk about it within that. There's also the extreme value theorem that says if your function is continuous, meaning if I trace it, my pencil doesn't have to pick up, on a closed interval, which means it has included endpoints, it doesn't go on forever, and the endpoints are included, then it has to have both a max and a minimum on the interval. Okay. All right, so the definition of relative extrema. If there is an open interval containing a value c on which f of c, the output, is a maximum, then f of c is called a relative maximum of f. It makes sense. Or you can say that f has a relative maximum at the order pair c, comma, f of c. So whatever that value is, you then plug it in to find your y value. Keep in mind, when you say f of something, you are talking about an output, and the c value by itself will be your input. Likewise, if there's an open interval containing c on f of c, and it's a minimum, then f of c is called a relative minimum of f, or you can say that f has a relative minimum. So absolute or global means it is the absolute biggest one or the absolute smallest one, but any sort of dip, any low point where it's going from high to low back to high is going to be some sort of minimum. Just like if I have going up to down, then you're going to have a maximum there. Okay, so these are our instructions for finding extrema on a closed interval. To find the extrema on a closed interval, you're going to find critical numbers. Okay, so critical numbers are going to be things that a critical number is going to be where f prime of x is equal to 0 is a place where critical numbers occur. And then also a critical number is where the function does not exist, where f prime does not exist. So if it's not differentiable at a certain place, okay? And then also your endpoints are going to be critical numbers. All right, and then at each of those values, when you find those values, you'll evaluate them for f at each of those values when you plug them in between the intervals and then at each endpoint. So these, you're evaluating your critical numbers, and then this is your endpoint. So you're doing all of those. And then the smallest of those values will be the minimum, and the biggest of those values will be the maximum. All right, so we're going to do a few examples. These examples are also in your textbook if you need to reference them. So the first we're going to do is find extrema of f of x equals 3x to the fourth minus 4x cubed on the closed interval. I say closed because it has bracketed encasings, and negative 1 to 2. So we first need to find our critical values, or critical numbers as they might call them. Okay, so critical numbers are going to be where f prime of x is equal to 0 or where it doesn't exist. So let's look at f prime of x. So when I do the derivative of f, I'll have 12x cubed minus 12x squared. Okay, that is a polynomial, so it is defined everywhere. But we can figure out where it's equal to 0 by factoring it. So I'm going to factor out a 12x squared, leaving me with x minus 1 equals 0. And so then when I solve that, I will get x equals 0 from the 12x squared equals 0, and x equals 1 from the x minus 1 equals 0. Okay, but then I also have my endpoints. So then now we're going to look at, if you look back at your instructions, it says to evaluate f at each endpoint and evaluate each critical number. So that means we're going to look at f of -1, f of 2. Those are my endpoints. We're also going to look at f of 0 and f of 1. Okay, and so we're just going to plug those values in to the actual function, not the derivative, the actual function. So we're plugging these numbers in here. So I'm going to have 3 times -1 to the 4th power minus 4 times -1 to the 3rd power. Okay, so f of -1 is going to be 7. F of 2 is 16. F of 0 is 0. And f of 1 is -1. So the biggest is here. So we're going to have a maximum here. And we're going to have a minimum here. So we have a max at the ordered pair, 216. And we're going to have a minimum at the ordered pair, 1, -1. So it's input, comma, output. Okay. And if you think about this logically, if you think about what a derivative is talking about, we've talked about like where they're equal to 0. If you have like a curvy line or something like this, you know, here's a max, here's a min, here's a max again. But if you notice, those slopes are 0 at the maxes or the minimums, because we talked about horizontal slopes being 0. Okay, and slope of tangent line. So that's why we do critical numbers equal to 0. And then your endpoint is where it ends. So obviously it could affect a max or a min. It's going to stop. So there's nothing to the left of it, meaning it's smaller than something to the other side of it or bigger. All right, find the extrema of f of x equals 2x minus 3x to the 2/3. So same thing. We're going to find our critical numbers. So we're going to look at f of x first, f prime of x first. The derivative of 2x is just 2. The derivative of 3x to 2/3 is you're going to have to multiply 3 times 2/3, leaving you with just 2. X to the 2/3 minus 1, which is -1/3. And so we have this as our derivative. So we've got to figure out a good way to solve it. Okay, so one thing I would do, we do need to figure out where it's equal to 0, but first I would simplify it. So I would rewrite this like this, and then you do several different things. You get a common denominator if you wanted to, but actually what I'm going to do is I'm going to add the 2 over x to the 1/3 to the other side so that I have this. So that if you look at a fraction equal to fraction, I can cross multiply. So I have 2x to the 1/3 equal to 2. And then I can divide both sides by 2. And then I can cube both sides. And I'll have x equals 1. Okay, so then I have those values here, but you also have to talk about, so that's where that is, but where it doesn't exist, if you look, my derivative also doesn't exist at 0. I can't plug in 0 here. Let me change colors. Because I would have an undefined value there. Okay, and so we have a critical number at x equals 1. We also have a critical number at x equals 0, okay, because it makes my function undefined. And then I have so let's write undefined at that. So that'll be a critical value. And then we also have our endpoints of -1 and 3 because of closed interval. If it was an open interval, you wouldn't include those values. So let's look at f of -1, our endpoints, f of 3, our critical number that we found from f prime of x equals 0, solving that, and then our critical number from where it was undefined, f of 0. So we have these 4 values that we're plugging in. Okay. When I plug in -1, I get -5. And again, you're plugging these into here. That's why there's not a prime. We have f of -1, not f prime of -1. When I plug in 3, I get a strange decimal. It's going to be 6 minus 3 cube root of 9, but it's approximately, just comparison's sake. I don't need to go out too far. I just need to compare if it's bigger or smaller. So it's about -0.24. And then if I plug in f of 1, I get -1. And if I plug in f of 0, I get 5. So my biggest output would be here. And biggest output is here. And my smallest output is here. So then I'm going to have a maximum at the order pair -1, negative. Well, I'm getting my max and my min mixed up. All right, we've got a maximum at 0, comma 5, and a minimum at -1, comma -5. All right, we'll do one more. Same concept. We're going to find the extrema of f of x equals 2 sine x minus cosine of 2x on the interval 0 to 2 pi. Okay, and so we're going to look at all of our values that happen here. So first thing, though, we need to talk about the derivative. F prime of x equals the derivative of sine is cosine, so we're going to have 2 cosine of x. And the derivative of cosine is negative sine, so we're going to have a negative of a negative, so plus sine 2x. And you're going to have to chain rule it because it does have a composition there. So then times 2, but I'm going to multiply that 2 into the front. So don't forget to chain rule that. All right, equal to 0. So then this is going to be an interesting thing to solve. We're actually going to have to use some pre-calculus to do that. Also, it's defined everywhere because sine and cosine are continuous. So we don't have to worry about, on the last problem, we had to talk about where the derivative was undefined because we couldn't plug in a number. This one is continuous everywhere, so we can be fine with that, but we still have to figure out where it's equal to 0. So what we're going to do is, it's really hard to figure this out with a 2 in that sign, but there is something called the double angle formula from pre-calc. And the double angle formula says that if I have an angle doubled in my sine, okay, I can rewrite it as 2 sine of that angle cosine of that angle. So then if you look at the inside of those sine and cosine, they no longer are doubled. And so I can rewrite this as 2 cosine x because that's fine. And then plus 2 times my double angle formula, which is 2 sine, instead of u, we'll use x, cosine x, still equal to 0. So I have this function here. So if you notice, they both have at least 2's. This one, the one on the right has 2 2's. And they both have cosine. So we'll factor that. So I'll factor out 2 cosine x, leaving me with 1 plus 2 sine x equals 0. So then we have to figure out where cosine of x is equal to 0 and where 1 plus 2 sine x is equal to 0. Or in this case, subtract 1, divide by 2, where sine x is equal to -1/2. Okay, is what we're going to be looking at. So if we talk about our unit circle, to help us out, we are trying to figure out where cosine is equal to 0. Well, it's cosine, comma sines. We're looking for x values that are going to be 0. So that happens here and here. Okay, and we're only going from 0 to 2 pi, so that's one rotation around the unit circle. We don't have to go more than once, so we don't have to talk about the other ones. So in this one, x is equal to, this is pi over 2, or 3 pi over 2. And if you struggle with your unit circle, you probably need to take it back to our chapter P and pre-calculus and review some of those things. So that one's done. So those critical values there. And then we need to look at our critical values for the sine function. So where is sine equal to negative 1/2. Well, if you think about it, sine is 1/2 often, okay? Sine is 1/2 because you have root 3 over 2 and you have 1/2. So sine is going to be 1/2 anywhere that your y value is not very tall, okay? So if we have our pi over 6, this ordered pair here is root 3 over 2, comma 1/2. Okay. So that one is a positive 1/2, so sine is 1/2. But here, it's talking about your x values. Here is the ordered pair root 3 over 2, negative 1/2. And then here would be negative root 3 over 2, negative 1/2. And then this one would be a positive x value. So really we're looking at these two values. You just got to figure out, well, where is that? Okay. So that's not too bad when you talk about where those values are going to be negative. Okay. You have to remember back to where we were. So I always like to think this is pi over 3 here. Okay. And that root 3 over 2 over negative 1 and negative 1/2 ordered pair, that is 90 degrees from that pi over 3. So that is a pi over 2 over that pi over 3. And if you have memorized, it's not a big deal. But pi over 3 plus pi over 2 is going to be 7 pi over 6. So one of our x values that gives you negative 1/2 is 7 pi over 6. Okay, you would not put these in your calculator and use the inverse sign and get a decimal for a problem like this. Okay, and then you would also have to figure out where this guy is located at. And I kind of look at him. If you notice, he is 180 degrees from this guy here, which is pi over 6. And so we're going to add, since it's 180 degrees, we're going to add pi to pi over 6. Oh, no, this one's 7 pi over 6, sorry. This one's 7 pi over 6. Because we're going to be adding pi there. So that one is positive. So we do need this one. And so this one is negative root 3 over 2. Or 1/2. So this one's 7 pi over 6. We don't actually need this ordered pair. I was getting my x's and my y's mixed up. I need to go back to algebra 1. And so then we have to do this one. And if you look at this one, though, it is, you can think of it a different way. If you look at where it's located at, this guy here is 2 pi. Again, this is a method if you don't have it memorized, you have to calculate. If you have a unit circle memorized, then this is a lot quicker. But if you don't memorize, then you just have to do math. So this is 2 pi. If you notice, he's going to be the same distance from this as this guy is, which is pi over 6. So we're going to do 2 pi minus pi over 6. So you would need to get a common denominator for that. And so you would end up with 12 pi over 6 and pi over 6, leaving you with 11 pi over 6. So we have those two. Okay. So if you notice, we actually have 6 things we have to plug in because we also still have to plug in our endpoints. So I'll do our endpoints. We have f of 0, f of 2 pi. We have f of pi over 2. We have f of 3 pi over 2. We have f of 7 pi over 6. And f of 11 pi over 6. So when I plug those values in, f of 0 is negative 1. F of 2 pi is also negative 1. If you're not sure about that, you'll have to calculate it. And again, you're plugging these in here using your unit circle. So just remember, sine is your y values of your ordered pairs. Cosine is your x values of your ordered pairs. And you do have to double the number when you plug it in there. Okay. All right. And then f pi over 2 is going to be 3. And f 3 pi over 2 is going to be negative 1. F 7 pi over 6 is going to be negative 3/2. And f 11 pi over 6 is also negative 3/2. So the biggest value we have is here. And these two tie for the smallest values we have. So we have maximums at the ordered pair, pi over 2, comma 3. And we have two minimums at two different ordered pairs, 7 pi over 6, comma negative 3 halves, and 11 pi over 6, comma negative 3 halves. Okay. If you want to pull up a copy of your unit circle, a lot of problems like that can go faster, but you do need to work on either memorizing them or knowing how to calculate the values on them. I just try to memorize the first quadrant, and then I can kind of muddle through and get the rest of it.